Hello and welcome to another video with Computer Science Bootcamp. So what we're going to be doing today is we are going to be delving into the world of object-oriented programming in Python. So object-oriented programming, once you know the theory behind it, you pretty much are able to put it into any language. Once you've practiced, it's pretty much the same in any language. So let's kind of do a bit of theory before we actually delve into programming. So object-oriented programming is a paradigm that focuses on creating objects that have their own unique behaviour and attributes. There are four main concepts in object-oriented. There are encapsulation, abstraction, inheritance, and polymorphism. So encapsulation is the process of hiding the implementation details of an object and exposing only the necessary information. So this helps prevent external code from modifying an object's internal state in a way that's not fully intended. Abstraction is the process of defining a simplified interface, for a more complex object. So this helps make code more maintainable and easier to understand. Inheritance is the process of creating a new object from an existing object. So the new object, which is now called the derived class, inherits all of the properties and methods of the existing object called the base. This helps to reduce code duplication and also allows for more modular code. And then finally, we've got polymorphism. Polymorphism is the ability of objects of different classes to be treated as if they were the same type of object. So that allows more flexible and modular code as well. So now that we've kind of had a little bit of an introduction to that, what I am going to do is I'm going to give you an example of how we design classes. So before we actually start coming into the coding section, let's have a look at designing. So I've just got a paint package open, that word. I'm just going to create a rectangle. I don't know why it's red. And then I'm going to split it into three. So that's going to be name. And then we'll split this section into two. So we're going to focus on a dog for now. So we're going to have a dog class, just because it makes it a little bit easier to explain. So in here, this section up here, I'm going to write dog, like that, the name. And then this section here is for the attributes. So these are the things that make a dog a dog. So if we have things like teeth, name, fur, tail, what else does it have? Legs. So that's 4 legs, doesn't it? 4 legs. Eyes. And then this section down here is for the attributes. So the methods. So the methods are things that a dog can do. So a dog can run. It can bark. It can listen. It can see. It can jump. It can sleep. There's lots of things that a dog can do. So these are all of the things, or this is how we design a class. So the first thing we do is we think of a class name, so dog, and then we think of the attributes that make it up to be a dog, and then we think of the methods, so the things that a dog can do. So now we've kind of got that class sorted. Let's see how we turn it into code. So I've got a VS Code already open, and let's start by naming the class. So the class's name was dog. And then, rather than doing all of the attributes that make it up a dog, let's just pick 2 of them. So I'm going to pick name, and I'm going to pick... there's one that's not in there, but let's do breed. I'll do breed up here like that. B-R-E. Ignore my really bad handwriting. D. There we go. We've got name and breed. So I want to... actually create a method in here. So I'm going to do def. I'm not in capitals. In it, I want self in there, I want name in there, and I want breed in there. And then what I'm going to do here is I'm going to say that the name is going to be equal to name. And I'm going to say that the breed is going to be equal to breed, like that. So we've dealt with the attributes. So now we need to deal with the methods. Now I'm just going to pick bark because it's easier. So bark like that. I'm going to pass in there self as well. And then I'm going to create a new print statement that goes print like that. Okay. So now we've done bark and we've done breed and we've done the attributes. Let's create another method that actually allows the class to deliver the information that is stored. So if we do def info, and we'll pass into itself, and then we just want to print, and we're going to do f my name is, and we're going to do self dot name, so whatever the user states the name is, and I am a self dot breed, whatever the breed the user states. Now at this point this isn't going to do anything because we've not actually created any objects. So in the example that we've just created, the dog class has two attributes, name and breed. There we go. And it also has two methods. It's got woof, which is bark, and it's also got my name is blah blah, and that comes under the info method. So we've also used the init method, which is a special method. It is basically called when an object is created, so it sets the initial value of the object's attributes. So let's go ahead and create a method, an object. So I'm going to come out of all of that. So to create an object of a class, we can simply call the class like a function and pass in any required arguments. So we're going to create two dog objects. The first one is my dog, and I'm going to set that to equal the dog class, and the name is going to be Max, and the breed is going to be Labrador Retriever, like that. So okay, so that's one. So I'm going to copy it again, and we're going to create another one this time. This time it's going to be called your dog, and the name is going to be Buddy, and he's going to be a golden retriever. Okay, so now we've created these objects. So all we've done is basically said, I'm going to create a new object of the class dog, and I'm going to have a name of Max, and I'm going to have a breed of Labrador Retriever. On this side, we've said, I'm going to create a new instance of the class dog. I'm going to call my name Buddy, and I'm going to also be a golden retriever. So to access them then, we need to do something like this. We need to go print my dog dot name. What do you think will happen? Pause it for a second and see what you think will happen. And now I'm going to do it. So it prints out Max. So it takes the fact that for my dog, is called Max, so the name then becomes Max, and the Labrador becomes breed. So what if we wanted to do breed then? So we do print my dog dot breed, and we do the same thing. There we go. Max is a Labrador Retriever. And we can do the exact same thing for your dog. So I'm just going to move these around just so we can keep my dog and your dog separate, just so it doesn't confuse me. So this becomes your dog, that becomes your dog. So Max is a Labrador Retriever, Buddy is a Golden Retriever. So we've actually just created an object here, and instead created an aspect of that object, and then we've called it and accessed it. So what about calling methods then? Because my dog, Max, is quite a vocal dog. So let's invoke it then. So we're going to go my dog dot back. So if I run that, so what will happen then is Max, Labrador Retriever, he says woof, but Buddy doesn't say woof. Okay, now it'll work for Buddy too. So we'll do your dog dot back, and we'll run that. So now Max is a labby, he's woofed, Buddy is a golden retriever, and he's woofed as well. So what's happened here is basically we have called the method. So we've used the object, your dog, which is linked to the actual class of dog, and we've just asked for a method to be run. So if we go up here, We've got a class called dog, which links into there. We have a method called bark, which links into there. And we've just asked it to run. I mean, let's just do the last one just for the sake of it. Like that. And then your dog.info like that. And then we'll run that one. So hang on, let's scroll up. So we've got max. Let's do Control and N and clear it, and then we'll start it again. So we've got let me just do that. There we go. Max is a Labrador Retriever. He says woof. Then we've got Buddy, who's a Golden Retriever, and then this is the one we just run. Max, Labrador Retriever, woof. Buddy, Golden Retriever, woof. Labrador Retriever, woof. My name is Max, and I am a Retriever. And then it's run it all again, and it says my name is Buddy, and I am a Golden Retriever. So we've just called all of the methods that are inside that class. Now, because we've got two dogs, what would have happened before is I would have had to copy this, and inside name I would have had to have done this. I'd have had to have gone around. Name is let me do it right. Max. Breed is Labrador Retriever. Probably should have chosen one that I could actually spell, shouldn't I? There we go. And all of that stuff. Then we'd have copied it again. Gone down here. Gone dog 1. Not Max anymore. Buddy. And he's a Golden Retriever. Like that. And then that's how we'd have done it. And basically we'd have called it again. But that's extra code. And that's just kind of annoying. So we don't do that. It's easier just to create a class for a general dog. I'm going to just get rid of Max. There we go. For a general dog. And then choose how to customize it later. So that's calling methods. But what about the fact that my dog, Max, really likes to swim, but Buddy doesn't like swimming? So we need to kind of have a separate section. So I'm going to just draw a line in red down here. Because I want Max. I'm just going to do some text. So I want Max to inherit all of the things from dog. Can't spell. But I also want him to have an added method of swim. Okay, so it's out of Buddy and Max, it's only Max that likes swimming. Buddy doesn't like swimming. So I need to find a way to actually help that, to make that happen. So how I do that is I can use inheritance. I can create a class called Labrador, and I'm just going to copy this because I will spell it wrong 50 times, and this way I know it's right. Labrador Retriever. And in there I'm going to pass in dog. So what this means is I am passing all of this information into this new class. And in this class, I'm going to do def init, and I'm going to basically create a super class. So I've passed in name, I've passed in breed, super init, but I'm going to take out breed this time of here. And I'm going to take breed out here. So we don't need that. And I'm going to put Labrador Retriever in there. Okay, and then I'm going to create another function called swim, and I'm going to pass in self, and I'm going to put print f, wrong way around, f like, oops, there we go, we'll get there, and I'm going to do self name dot name is swimming, like that. Okay, so what's going to happen here is this new class is going to inherit everything that's already inside dog. So I can call Labrador Retriever and still call info, and it will still run. So we're going to just we're going to just tag out all of this for a second, because we're just not going to work with your dog for a while. I'm going to get rid of this for a second, like that. And what I'm going to do is we're going to try and call it. So let's do, so my dog, I'm going to change my dog to Labrador Retriever there. To change the class, And I'm just going to see if this works. I'm going to do my dog dot info. I'm going to prove to you that I can access all this information. And I'm going to run. 2 position arguments, 3 were given. Is it because name? I had this. How did I fix this? 1 second. Right, we don't need Labrador Retriever anymore because Labrador Retriever's up there. So we just need Max. There we go. So my name is Max and I am a Labrador Retriever, and I've probably spelled Labrador wrong, but that information there comes from this section here, which is linked in to the class dog. So we have basically inherited everything out of there and put it into here. So let us try the swim. So I'm going to do my dog dot swim like that, and we'll run it. So it's obviously said that first, and then it goes Max is swimming. Now if I did your dog here, okay, and then I tried to call your dog dot swim, it wouldn't quite work. It wouldn't look like it works. Like, it's gone green here, but it's still white here. And if I try to run it, it'll come up with an error. And that's because your dog has not actually got the Labrador Retriever class. Your dog is still stuck on dog. And that's because Max likes to swim, but Buddy doesn't like to swim. Therefore, there's no need for Buddy to actually be in that class. So that is inheritance as kind of like a whole. So let's kind of take this then and see how this would look in a command line calculator. Just a very simple one. So I'm going to Control A and not get rid of all that. I'm going to Control L there. And let's use a class called calculator. It's one of them words that is really difficult to spell. And we're going to do a def in it again. There we go. And I'm just going to get rid of that, so we don't need that. And we'll keep that as it is for now. I'm going to create another one called add. And I'm going to pass into that self and A and B. So we're not going to do a GUI calculator today. We're just going to do a simple calculator just to show you how inheritance works and how object-oriented works. So if we do return A plus B, like that. And then because I'm lazy, I'm just going to copy this. And this time it's going to be subtract. Subtract. And I've got my C and my T the wrong way around. And we're still going to have self A and B. But instead of plus this time, we're going to be minus. And I'm going to do the same again for multiply. And A and B is going in, but we're going to just do multiply instead. And one more for divide. And this time we're going to do like that. So I've created one class, okay, called calculator, and I've given it a lot of functions. Now, let's just work on the divide a little bit, because note gets my goat a little bit rather than being able to divide by 0. So I'm going to do an if statement that says if B is equal to 0, then I want you to return, we'll do it this way, I want you to return cannot be divided by 0, like that. Else, I want you to return A divided by B. So what this means is if you do 2 divided by 0, because the B value is 0, it won't actually divide it, it'll give you this message instead. So the init method, we don't really need to do anything, we just need to include the word pass. And then we've got the add, subtract, multiply methods that take 2 arguments, A and B, and they also perform the corresponding arithmetic operation, which is here, 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 and here. And then if we try to enter in a value of 0 as our dividend, so the one that we're going to divide by, it will say that it cannot be done. So the next thing we need to do is now we've created our class, we need to actually create a object. So we would do that by going my calculator equals calculator, like that. Okay, so now we've called that, then we need to use the calculator to perform the operations. So we can use my calculator now instead of calculator. So for example, we can do result equals my calculator dot add 2 3, like that. Then we could do result calculator equals divide, let's think of some numbers, 8 and 2. Let's keep it simple. Subtract, we'll do subtract 2 and, no, that'll be a minus number, 2 and 1. And then multiply, yeah, we'll do 2 times 3. So once we've done all of that, we would then just print out result. So we would go print result, like that. And then we do, I don't know why I did it twice, like that. So all we've done is we've said, this is my class. I want to create a new object of that class. I want to add 2 and 3 together. I want to divide 8 by 2. I want to subtract 2 from 1. I'm going to change that round actually. Do it like that. And then multiply 2 and 3 and then print the result. So run Python. So 5, 4, 3, 6. Perfect. So in each example, you've called on the method that is stored in my calculator, which is now the object of class. We've got 2 arguments, A and B, and they basically just perform each of the elements. So that is kind of like a whistle-stop tour of object-oriented programming. So we've looked at what the theory is, and then we've kind of gone in and had a look at each element separately, and then we've created a very simple program using object-oriented programming. Again, there's lots of ways you can make this better, but that is now down to you. So that's it for now, and happy programming.